baud rate. What is a baud rate? So baud rate is refers to the total number of signals units transmitted in 1 second. This is the definition you need to give. What it means. So whatever the signal, if you say 1 and 0. Okay. So next we have a 1 and that's it. This is ended up. This is a 1 signal. Let's consider that this is a 1 signal. So here I am transmitting 3 bits per second. Okay, so this is a 1 signal. Okay, so this 3 bits is 1 signal. Okay, this 1 signal I am transmitting it. So what this signal contains? This signal contains ones and zeros, because whatever the microcontroller required, we required the bits informations, right? Ones and zeros, because of the digital transaction or digital transmission. Okay, so baud rate refers to the total number of signal units transmitted in 1 second. Okay, and next is baud rate is the rate at which number of signals elements or changes to the signals occurs per second. Okay, when it passes through the transmission. This is let's say lengthy definition. I can say whenever your interviewer asks you, you need to give this definition. Okay, so just this is for your understanding. Okay, number of signals element changes to the signals, okay, per second when it passes through the medium. Like medium is wired or wireless. So whatever the changes it's happening, right? So within the wire, so that will define as the baud rate. Is it clear? So the higher the baud rate, the faster the data will be sent or received. Okay, this is the one important point. In interviews they will ask you, if baud rate is higher, the data is faster or sent or slower. Like that, the interviewer will ask you. So you need to say that higher the baud rate, faster the data will be sent and received will be happening. Because when you are working real time or the concepts, okay, the interviewer expect that how much efficiently you learned on the concepts. Okay, so this definition you need to give. And next is like for understanding, just I given the formula. Baud rate is number of signals element changes per unit. So for the same above. And next is coming to the bit rate. Okay, what is a bit rate? Number of bits transmitted per second. How many bits I am transmitting? Like whether I am transmitting 8 bits per 1 second or 9 bits 1 second. So that will be defined as the bit rate. Okay, you need to write down bit rate is the number of bits transmitted per second. These are very important, guys, which are I am highlighting now. Those points are very important. You need to write the running notes, or you need to write the notes after the video is shared to you. Okay, bit rate is the number of bits it transmitted per second. Okay, and next is bit rate is equals to, like if we compare with this formula, the bit rate is equal to the baud rate into number of bits per second. Okay, so this is the formula for bit and baud rate combination. Okay, so let's consider example here. 1500 I given the baud rate. Okay, so that indicates that 1500 times per second. Okay, 1500 per second. So what it means, so whatever the data that we are transferring, right? So the changes, it refers to the 1 to 0 or 1 to 0 up to 1005 times per second. So like if I say 1 to 0, right? This is one time, and this, and again 0 1 to 0 to 1, like this. Okay, like this is a complete cycles. Okay, so like how many times it should happen? It should happen 1500 times, okay, per second. Means whatever the data that I am transferring, this is a 1 bit, this is another bit, this is another bit. So like this, the continuously 1500 times, whatever the cycle you are seeing, right? Whatever the rising and falling of ones and zeros, it happened 1005 500 times per second. We cannot imagine like how much time the data bits got changed it. Okay, that is a part of the bit rate. Is it clear about bit rate and baud rate?
Yes.
Here, in this slide, the important points are the this, and next will be the part of this definition. Okay, and for your understanding, just to know like about bit rate. Next, we'll talk about what is a frequency in detail. Okay, so as we know, that is a 1 second. Okay, so 1 second, one per cycle per second. Okay, so what it is? So one cycle is we are making the one rotation. Okay, so it is a like a 360 degrees rotation. This is one cycle. Off cycle means 180 degrees centigrades, and off another off is 180 degrees centigrades. It will be like that. In between, it will be the 90, and in between of 180 to 360, it will be the 270. Okay, and within 1 second, how many cycles is happening? If you see here, it happened 2 cycles. 2 cycles per second. Is it clear? 2 cycles per second. Is it clear for you how this 2 cycles per second came from this diagram? 2 cycles per second. Is it clear? Like how I'm getting it? Because this is diagrammatic to understand that two waves are generated within 1 second. Two waves, 2 cycles. Like consider 2 cycles or two waves are generated in 1 second. Okay, so within 1 second we got 2 cycles and two waves. Okay, and similarly what is happening is whatever the 2 cycles it is make and in 1 second. Okay, so that 2 cycle we called as the edges. So the frequency is 2 edges. Okay, and similarly if I say that I have it 3 waves, like assume that I have 1 wave, 2 wave, 3 wave. So 3 waves are generated in 1 second. So I have 3 waves. 3 waves are generated in 1 second. Now what is the frequency? 3 edges, right? Guys, are you there?
Yes, sir.
Okay. So like this, we are calculating the frequency depends upon the number of waves it is generating. Okay. If we say that in the chargers or in the mobiles or the clocks, we always discover about the edges. Edges means the frequency that is generating from the devices. Okay. So that's what whether it will be the wire or wireless or the devices which we have the mobiles and the system, laptops and the microcontrollers. The edges means that many times the cycle will we are completing it. Okay, so instead of this is a sinusoidal waves. Okay, so in our digital way how it will form is this is one cycle. Okay, so in digital way it forms like the square waves. Okay, so this will be the square waves. Okay, so here this until from here to here. Okay, just from here this will be one cycle. Okay, it have 360 degrees. It just I'll make it redraw for you to understand. Okay, this is a sinusoidal wave. Okay, sine wave, and in the square wave, how we will get? So we'll get like this. Here it is there. So again, So like this is a one cycle in the square wave. We are getting it, okay? In the so whenever it is from this matching point, it will be the 180 degrees centigrade, and this matching point it will be the 360 degrees centigrades. Okay, this is the sine wave and the square wave. That is a for the digital things. It will be like this, and for analog it will be in the form of sine wave. Okay, so that is what the frequency to get. So whatever the uh, signal frequency is the number of cycles per second that signals completed. Whatever the comma signals that it will complete, right? Here it is completing within 1 second, 2 cycles are completed. Okay, that is the frequency. Okay, so frequency is the number of oscillations per second. You can give this definition also. Frequency of a sinusoidal wave, whatever the sine wave, as the number of completed oscillations made by the element of the wave per unit. Okay, this is for just understanding. In the real-time scenarios, we have whenever the wave, it will be defined. So the height, right here from the point. Okay, this we call as a amplitude. Amplitude is the height of the wave, how much it is rising. So that will be the amplitude. Okay, height of the wave rises. Wave rised. Okay, and next coming to the one cycle, it will be here. As we know, from here to here, it will be 360 degrees cycle. So this will be the one cycle. Okay, so here I'm making as a one cycle, and we have the wavelength. Wavelength is the rising point of the two edges. Okay, so it is a fall bottom ones. Similarly, we have the high from the top. This will be the two rising edges we called as a wavelength. Okay, so this is a wavelength of the top, and this will be the wavelength of bottom, two rising points. So that difference will give the what is the wavelength of the signals. Okay, and here wave is a disturbance that travels through the medium from one location to the another location. Okay, that is a wave definition. And time period of oscillation of wave is defined as the time taken by any string element to complete an oscillation. Okay, so wavelength and time period are interrelation. Okay, so that formula will tell you of that. So as we discussed about a higher frequency and lower frequency, when we keep the higher frequency, more number of waves will be generated. If we keep the less frequency, the less wave cycle will be generated. Okay. So this is a difference. Here I have a one question for you all. Which is the faster and which is the slower here?
1 Hz is the fastest, sir.
Okay.
No, 3 heads.
3 Hz.
Just as a first.
Yeah, this is the
3 Hz.
3 Hz is the faster. Yes, because of the higher frequency, more number of waves it transmitted, and it is a faster.
Lower wavelength.
Lower wavelength. Yes. Good. It is the inversely proportional of the wavelength and frequency. We have the definition for that. We'll learn it further. So next is coming to the UART protocol. Okay. So we need to know about the how data will be transferred from one device to the another devices. Okay. So what is the baud rate we are setting? What is the frequency? It will be defined. We'll going forward. We'll understand this. Okay. Write down UART. Write down UART. The full form of UART is Universal Asynchronous Receiver and Transmitter. So U stand for universal, A transfer the asynchronous, R for transfer receiver, T transfers transmitter. Okay. So like it is a low speed. Okay, and where we can use the off board. That means off board is like the connectivity of the controllers directly we can use, and it is a full duplex. We have full duplex and off duplex as well. And Yeah, we'll understand from the UART. Okay, so what is the full duplex? What is the off duplex? Both. And mostly we are using for the GPS and modem purpose and some of the terminals. Okay, and it is a peer-to-peer communication. So one-to-one connectivity. This is a overview. Don't consider these points. So just consider UART. So like if you are able to see, right, this is the transmission medium here. It's happened. It will be. So whatever the data that you are transferring, it will be transmitted to the receiver end. Again, from the receiver, the data is repeating. Okay. So sorry. So here, this guy will be the sender, or we can say that the client, and this will be the server. So like this guy is sending the data, some data we don't know, but we need to know like how the data will be transferred and all. Okay. So next from the receiver, server end, it receives the information. Again, receiver end, it will transfer the data to the client. Okay, this will be the receiver. So here we have a two lines. The TX transmission will be happening and receiving also will be happening for two lines. Okay. So here you need to understand about what is the synchronous and asynchronous. Okay. The protocol which we talk, right, the full duplex part, it will be the UART. UART is UART, universal, synchronous and asynchronous. So UART is, it will work for both full duplex and off duplex. Okay, coming to the UART, it will work only for the off duplex protocol. Okay, so this is the main difference of synchronous and asynchronous and synchronous. Synchronous is which carries the start and stop bit between the data. We have the data here. So we know I told you in the network protocols that synchronous it have the start and stop bit, whereas synchronous we don't have the start and stop bit. It depends upon the clock only the data will be transferred. Did you remember all these points?
Sir,
Yes, sir.
you want full duplex, sir?
Sorry.
Sir,
Yeah.
you want full duplex or half duplex, sir?
Off duplex.
Like before slide, you mentioned like full duplex.
Yeah,
Full
yeah.
duplex.
As I told you, like UART, we have two types. Okay. One is UART. This is the one, and another one is the UART. Okay. UART is universal, synchronous, asynchronous receiver and transmitter. Universal, synchronous, asynchronous. Okay, S is stands for synchronous, A stands for asynchronous, and receiver and transmitter. Okay, it can act both off duplex and full duplex. Okay, so this is a UART. So this is a synchronous protocol where we are using in SPI protocol and I2C, some of the other applications. Okay, other application protocols. This is where this synchronous means it requires the clock for transmitting of the data. Whenever you are sending some data, you need the clock. Without clock, data cannot be transferred. Is it clear still now about UART? You did got a confusion. We are discussing about UART. Now coming to the UART. UART is the what we given the definition, no? Universal, asynchronous, and receiver and transmitter. So this is an important concept for us. So that's what like we are considering the UART. So that's what I told to write the notes as a UART. So in UART we have it is a asynchronous transmission. It have the start and stop bit, and in between that data will be transferring. Okay, is it clear? Still no? Don't get confused. Okay, so you need to consider UART. It is a off duplex and asynchronous communication protocol. Okay, is it clear?
Yes, sir.
Yes, sir.
Okay, some they will mention in the websites or some documents also they will be mentioning that UART is a full duplex protocol, but it's not. It is a comes under a part of a UART. UART it have the full it have a flexible of transferring the data. Whenever you remember, guys, always. So the synchronous and asynchronous. So synchronous is with respect to the clock. Asynchronous is with respect without clock. It have the start and stop bit. And other point you remember, this synchronous have always full duplex protocols. Okay, full duplex it have, off duplex it have. Okay, this is a real time keywords. Okay, so you need to remember it have both full duplex and off duplex, but synchronous have always off duplex protocol. Okay, so that is a 2 points you need to remember. Don't get confused here. So in websites they will mention that UART is a full duplex off duplex. To get, you can also get confused, so don't go with that. So whatever the given notes, you can go through it. It will be help you for understand better. Okay, so remember, this is a separate for UART is a separate one, and another UART is the separate. Okay, so we are need to understand the asynchronous. Asynchronous is the without clock we are transferring the data, so it have the start and stop bit information. Within that only we are transferring the data. Is it clear? So we'll discuss individually to make it clear. UART is a universal asynchronous synchronous receiver transmitter. So whatever the data we are communicating, so that data will be communicated in the form of serial communication only, but with respect to the clock we are transferring. Okay, so mostly this is also a part of the hardware communication we are using it. And coming to the UART, UART is a universal asynchronous receiver transmitter. So where we are making the programming to the controller and we are transferring it. And what is universal? So it is called universal because it can be used in many different types of devices. Okay, so that's what, like it will be compatible, like you can align to the systems like laptops, computers, and microcontrollers. Some of the other devices we can easily connect and configure it. So that is what universal it means. Okay, this could be anything from the small sensor to the larger industrial missions. As I told you, like we can use anywhere. Okay, and generally it will be connected to one-to-one connection only. If I using a one microcontroller, other microcontroller, so in this this is we call as a one-to-one. Okay, one-to-one only I can connect it. One-to-one connection only it possible. So here, like we have a 3 lines. Okay, so you can write down the lines. So this is electronics, no? So we need to remember always the ground also it will be. So you will write down TX, RX, and ground. So from M1, this is a microcontroller 1, and this is M2. Like master and slave, you can consider. Master and slave. So from the master side, I'm transmitting the data. Okay, so it have the TX and it have the RX and the ground. From master point of view only, we are discussing master, TX, RX, and ground. If you see the diagram here, so this guy is transmitting means the other end is the receiver. If this guy is transmitting, the slave is transmitting means the master will be the receiver. So, okay, so here we may consider the TX, RX, and ground. In interviews, if they ask you like what is UART, so UART it have 3 lines. It have the TX and RX and ground from master to slave. It is a 3 pins. Next, it is a UART. Full form is Universal Asynchronous Receiver-Transmitter. So mainly, it is a every controller have this option. Okay, so like other protocols. So main function of the UART is serial data transmission. Whatever the data we are transmitting, right, that will be in the form of serial. We know about parallel data transmission and serial transmission, right? Did you remember? I told you in the network concept. What is a serial transmission? What is a parallel transmission? So serial transmission is one bit at a one bit we are transferring at a time, bit by bit we are transferring here. So on like 8 bits of data we are transferring at a time. That will be 1 second. You can consider like here it will be a 1 bit at 1 second. So that will be the serial transmission and parallel transmission. So that we discussed in the network concept. And in UART, the communication between the two devices can be done, namely like we know that parallel transmission and data transmission. So here in the UART, we have a option of sending the serial data and parallel data. Both way of communication is possible. That depends upon the connector, the DB connectors, as I told you, right? DB9. So DB9 is a serial. Similarly, we have a DB15 and DB21. Like those are used for the parallel connection. Okay, so we need to understand the real-time concept. So we'll go with the in the part of serial data communication. So the DB9 connector is the one which we used for sending of the serial data. Okay, what is the functioning of UART is it converts the incoming and outgoing signals into the binary data. And moreover, whenever you are transferring, right, the data, it will transfer only at one time. It will transfer 8 bits. Okay, so what it will do, it will convert sometimes depends upon the devices, right? So it should convert the serial to parallel conversion it required, and some parallel to the serial conversion is required, depends upon the devices. Okay, so devices communication. So in that purpose, this UART is more helpful for converting. Okay, so 8 bits data receives from the peripheral device. It converts into the parallel from using the serial to parallel conversion, or parallel data received from the CPU is converted using the serial parallel conversion. So that way, like within the interfaces, we can act it. Whatever data it is presenting, right? So the data which we need to transfer, so we are setting the baud rate. So with respect to the baud rate only, the data will be transferred. Okay, so how much, what is the baud rate? Baud rate is the number of signals transmitted per second, right? So what is the number of signals? That number of signals are the bytes of data that it is carrying. So why we are using the UART? So as I told you, like from the diagram, it is a converter. Okay, so here we have the 3 pins. Means whatever the power, this will be the ground. It will be the ground signal. Okay, so this part will be the TX pin, and this will be the RX pin. Okay, so default it have the voltages variation. Okay, so ground TX. So what is this is a USB. Okay, when we are using this will be the adapter. Like it's a kind of the converters. It will be USB to the serial adapters. Okay, so this is one part. Like whenever we are connecting to the PC to the microcontroller. Okay, so from the UART with these 3 wires, we need to connect to the microcontroller, and how we are connecting with the help of the converter, USB converter. Because our PCs have the USBs, right? So for that purpose, with these 3 wires, we are need to connect because to exchange the information, or to send the file of data, or to transfer the data, anything that we required. So protocols like even the other protocols like USB protocol, SPI protocols, so that are faster communication whenever the high speed of data is transferred. Okay, so depends upon the protocols. We are the be varied and the features will be varied. And next, even that it have the single transmitter and receiver. So the single wire for transmitting the data and other wire is for receiving of the data. So the RX and TX. And these are the some part of converters, so as we discussed from this block diagram. And like how the data will be transferred from one device to the another device. Okay, let's understand. So this consider this is the device one, the master, and this will be the slave. Okay, so how data will be transferred? So with what I told you, UART is the asynchronous protocol, right? So we have the start and stop bit. Now I transferring the data. So in coming to the frame, we have the D0, D1, D2, D3, D4, D5. So this all have the day frame, means whatever the bits have, it will be in the form of this. So, and we have extra the parity. Parity is for error checking. Whatever the information, the messages that we are transferring, right, the bits. So it should be verified whether it is the correct or not. Okay, like start is a 0. Okay, and next we have the stop bit, the data which it is a low. Next, this is the data, whatever D0, D1, D2 until D7, it will be the data. So wherever it is high, that will be a 5 volts will be given. Where it is low, it will be 0 volts. So 1 means always the voltage, remember, and 0 means there is no voltage. So 1 will be high, 0 means 0 volts. So like this only the data will be transferred, means that data only it will be stored in the memory. That data only we are able to monitor on the tools and ECUs in the controllers. Okay, so similarly, like we have the printers for transmitting of the data and receiving of the data. So when we like we are using some protocols, right? The UART. This is a UART DB9 connector. With the help of that, RS-232 is there. There is a cable. Okay, the way that we need to transfer the data from PC to the printer. So it have ones and zeros. That ones and zeros only it will be the information that will go into the printer. So there is a voltage levels for minus 32 to minus 25. That will be the voltages. This is the other interface protocol to the UART. So depends upon the devices, the voltage will be varied. Okay, just for to know and understand this concept. Yeah, so like what is the how the data will be transferred? So as I told you, like we have the start and stop it. Okay, you need to draw this frame, start and stop it. UART, write down the UART definition you completed. It is a asynchronous protocol and it is a off duplex protocol. You can write down duplex protocol. Okay, I will write it points wise. It is a off duplex protocol and it is a asynchronous it transfers serial data. It's specifically for UART. Okay, we can use the converters, but whenever we talk to the UART, the communication will be serial data only. We can convert the serial data to parallel data with the help of the converters. Okay, converters will be there. With the help of that, we can convert it. It transfers the serial data. It is asynchronous. It is off duplex protocol. And next point, you can draw this block diagram saying that the master and slave, if you drawn, it's good. Like who not completed, you can draw this. it have 3 lines. It have 3 lines. Means 3 lines means the wires. So transmitter, receiver, and ground. Okay, so these are the points you need to remember. And whenever I make some points to highlight a star or underlining that are important for interviews. Okay, so message will be transferred in the form of data. It can transfer. It can transfer. It means UART can transfer 8 bits. 8 bits at a time. 8 bits at a time. Okay. So next, it have start and stop bits. It have start and stop bits. Underline that. So okay. So whenever the data starts transmitting, right? That time it will be low. Means it will be a 0 voltage. Initially it will be 1. Okay, when there is no data transmission happening, that time it will be 1. Write down this is also 1 point and make it double star. Okay, so whenever no data transmission, in the network means in the protocol. Okay, in the UART, whenever no data transmission in the network, UART, in the UART message, the start bit will be 1 volts. It will be 1 only. You don't mention the volts. It will be 1. Okay, so write down 1 within the bracket. It will be 5 volts or 1 volt, anything that depends upon the devices and connectivity specification, because hardware dependent it will be. And next point, under this only you can write down whenever data transmission, that is no, this is transmission, data transmission in the UART, message, the start bit will be 0. This is very important. Okay, so this is ideal. Ideal means it's not no communication is happening. This is ideal. This is not ideal. Transmission is happening. Started transmitting the data. Started transmitting the data. This is the ideal condition. Okay, if you have a small bracket, you can write down it. This is ideal and this is started. Okay, and now the next point will be, so whenever this field, right, whatever the frame, like whatever the data that we are transmitting, it in the form of frames. Okay, so this frame, it stores only 1 bit. Okay, and next we have the stop bit, so it can store up to 1 to 2 bits. Okay, and we have the data, so it can store up to 1 byte of data. And we have a parity, so it can store only 1 bit. Okay, so 1 byte is 8 bits information. It will be transferred, and this is 1 bit, and this is also 1 to 2 bits, and this start bit will be 1 bit. Okay, so here whenever the data will be transferred, right? So that time it will be 0. Okay, now the data is transferred. So that is like D0, D1, D2, D3, so up to D7. So this is a 1 byte information. I am transferring it. And now we have a parity. This is a optional. Okay, this is for used for error checking. Error checking. Okay, and once the data completes, this should be stopped. Means whatever the data, it will securely started and ended. That's how the stop. Okay, so that is all about the frame. This is a very simple frame. We have a start, data, parity, and stop. The high level you need to make it. Is it clear? What is the how the data will be transferred in the form of UART? It will be transferred in the form of messages. You can write down the sum of the other points. Data will be transferred in the form of messages. In the form of messages. Okay, so you can see this is the part of understanding of the logics. So whenever the data is transferred, that time it will be raised. Okay, so for each and every data, there will be rising is happened and falling is happened. Okay, so this rising and falling instantly it is happening. Okay, start by detected transmission. This is just for understanding about the frame. So whenever it started, it rised and it fallen. Okay. So this is the data transmission. So usually how we are doing the connectivity. So in the hardware point, this is a one controller. From controller to controller connection, we have the ground pins. So and next this we have the transmitter here and receiver here. And again we have the receiver and transmitter. So like to understand this is a one part of microcontroller one and my another part of microcontroller. When we are doing the connection, right, the transmitter end we need to go to the receiver, and this TX pin we need to give to the RX. So like that we need to do the connection. Okay, and next in the hardware point we have the some other pins like TX and RX. So with the help of the schematics we can come to know on more this. And for this connectivity you have any other converters like parallel converters or serial converter, or if you need to introduce the USB conversion or RS-232 connection. So with the help of these schematics, we come to know the pin naming. Pin naming will be defined here: 1, 2, 3, 4, 5. So this is a 9-pin connector, as I told you in the microcontroller concept. So from the pin naming, based upon the pin naming, we need to choose from which pin to which I need to connect it. Just for general info. So like I have two controllers. Okay, this is the my controller 1 and this will be the controller 2. Okay, so here if you see the closely the block the diagrammatic simulation, here I have a RX0. So this RX0 is the green one, it is connected to the TX1, and from the RX0 to TX1. So like this I connected it. And next we have the LEDs here. Okay, so whenever you press the button of this M1, whatever the data it is there, it will move to the this controller, means from this pin it will go and the LED will blink. Okay, so this says that the whatever you transmitted, I received it. If I do the same button here, pressing of this LED will blink, means whatever the message it is there, it will be passed with the help of these two wires and it will give the information. Means it says that okay, I received the message. Okay, so this is an online platform. I will explain you this online platform. You can practice the UART communication, how it is happening. Okay, so like how generally we can connect. So we have the converters, so USB or UART connectors. With the help of the converters, we are connecting to our system, and we can do some part of doing the testing, like whether we to operate the motor or the buzzer or the LEDs. So all those stuff that can be performed by connecting the system. Okay. So like some data you need to transfer from the wire. This is a wire. So wire, here I can say it is a protocol. So the protocol is nothing but any protocol. We can use as a CAN protocol, we can as a LIN protocol, we can use as a UART protocol, we can as a Ethernet protocol. Anything that is used for communication purpose. Protocol is used for communication purpose. For communication means transmitting of the data and receiving of the data. That is what the communication. Okay. So the microcontroller, it have inputs and outputs. Additionally, we are supplying the battery as well. You are getting right? So our outputs are LEDs, motors, and some of the speaker. So like this, usually it have the output. Getting right? So to make the inputs and outputs programmable, we are doing in the system the programming. Based on the programming, the data that we are giving. So accordingly, the data, whatever we are giving to the controller, it will be processed. Okay, right? You are able to understand this block diagram? Getting right? సో ఇప్పుడు మనము ఈ మైక్రో కంట్రోలర్ అనేది మనం అర్థం చేసుకున్నాం. What is a microcontroller? So what are the components it have? And next is what are the inputs and outputs? We are able to understand. Now we need to understand the protocols. How the protocol is there and what are the protocols? How we need to work this protocol? How we are able to access the data? So మనం ఈ డేటాని యాక్సెస్ చేయాలంటే ఈ కమ్యూనికేషన్ డేటాని మనం ఈ టూల్స్ ఎలా యూస్ చేస్తాం. సో లైక్ వీ హ్యావ్ ఏ టూల్స్ ఆఫ్ కెనోయి టూల్స్. దెర్ ఆర్ మెనీ టూల్స్ లైక్ దట్ బికాస్ మోస్ట్ ఆఫ్ ద ఇండస్ట్రీస్ దే ఆర్ యూజింగ్ కెనోయి టూల్. సో ఈ కెనోయి టూల్స్ యూస్ చేసి మనము ఈ డేటా కంప్లీట్గా ఇన్పుట్ అవుట్పుట్ని కంట్రోల్ చేయొచ్చు అనమాట. మనం మాన్యువల్గా కంట్రోల్ చేయలేం కదా. సో విత్ ద హెల్ప్ ఆఫ్ ద టూల్ వీ కెన్ అబ్జర్వ్, వీ కెన్ సీ అండ్ వీ కెన్ కంట్రోల్ ఇట్ ఫ్రమ్ ద టూల్స్. మనం ఈ టూల్స్ లో ఆపరేట్ చేయొచ్చు. Is it clear? Vardhan, Anil?
Yeah, clear, so much.
So any doubts on this still? మనం ఫర్దర్గా మనం నేర్చుకోవాల్సింది ప్రోటోకాల్స్ అండ్ మనం ఏదైతే టూల్స్ యాక్సెస్ చేస్తాం కదా, ఈ టూల్స్ సాఫ్ట్వేర్ టూల్స్ నేర్చుకోవాలి అండ్ ఈ ప్రోటోకాల్స్ గురించి మనం స్టడీ చేయాలి. అండ్ ఫర్దర్గా ప్రాజెక్ట్ డిఫైన్ చేసేది ఏంటంటే లైక్ వాట్ టైప్ ఆఫ్ ఈసీయూ యు ఆర్ యూజింగ్. సో లైక్ ఎయిర్ బ్యాగ్ ఈసీయూ యూస్ చేస్తున్నామా, లేకుంటే అడాస్ యూస్ చేస్తున్నామా, లైక్ కెమెరా ఈసీయూ యూస్ చేస్తున్నామా, లేకుంటే ఇంజన్ ఈసీయూ అనేది మనం ప్రాజెక్ట్లో డిస్కస్ చేస్తాం. బట్ వీ నీడ్ టు అండర్స్టాండ్ నౌ. సో వాట్ ఈస్ ద మైక్రో కంట్రోలర్, వాట్ ఆర్ ద కాంపోనెంట్స్ ఇన్ ఇట్స్, హౌ వీ ఆర్ యూజింగ్, సో దట్ షుడ్ బి అండర్స్టూడ్. Okay, so now we need to go with the protocol. So let's go with understanding of the protocol. So we are started discussing about the UART. What is UART? Universal Asynchronous Receiver and Transmitter. Okay, it is a one-to-one communication. Here you are able to see this is the transmitter guy and here is the receiver wire. Okay, so you another wire you have, that is the ground common, it is for all the protocols. But most of the thing, whenever we talk about the protocol, we'll always discuss about who will take the data, the transmitter and receiver, who will take the data and who will receive the data. So this will be the master data who will sending the data, and here we have the slave. It is receiving the data. Again the slave will be transferred the data again master will receive the data. So like that, the mutually the data will be exchanged. So here the master is my PC, whatever we saw the laptop, and the here we have the controller. So that is the ECU. With the help of ECU, we connected the UART and we are communicating the data. So that data, what the data we are sending, what the data we are receiving, all that can be seen here. Is it clear? Is it clear about the UART understanding on top level?
Yes, sir.
Okay. So now it is a most one-to-one communication only. It is to device communication protocol. Okay. So what is universal? Why we call as a universal? We call universal because where we can connect with the different devices. Okay. So it can be used in many different types of devices. So that's why we call as a universal. Okay. And it can be anything like you can interface to the sensors or missions, any industrial things we can be used. That is a universal. So UART specifically universal asynchronous receiver transmitter. Okay, so it is used for programming of the controller, and we have a USART. USART is a universal synchronous asynchronous receiver transmitter. So it is a part of asynchronous serial communication protocol. So whenever it's the data you need to send, it should be depend on the clock, and you need to send the data. Okay, so mostly the protocol which we are discussing is the UART. Okay, so what is UART? So UART full form we discussed. So it is used for communication between the devices. So but I2C, SPI are other protocols that we used for communication of the processors or controllers within it. Okay, for the communication, I2C, SPI will use for the internal communication of the controllers, the processors, whichever we are seeing, the processor 1 or processor 2. Okay, but uh, it have a lot of difference. Okay, we're going forward, we'll learn about those. So the main function of UART is it is a serial data communication. Means whatever the data you are sending, it will go by ones and zeros, the bits only. Okay, so UART is used for mainly the communication between the two devices. It had two types, the serial data communication and parallel data communication protocol also. So but you need to remember whatever the data you are using for the UART, it is a serial data communication protocol. Okay, so we have two types, but remember only the serial data type, not this. Okay, so synchronous. So if you see, like we discussed, synchronous is nothing but clock dependent. Okay, with respect to the clock only, the data we are able to transfer. If there is no clock, if clock ends, the data will be ended. It won't send the data. So asynchronous is we have a start, we have a stop bit. We discussed about this. So remaining whatever we have the data. So whenever you need to send the data in the asynchronous protocol, you should have a start and stop bit. This is very, 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 very important, I can say. You need to know about synchronous and asynchronous. Okay, and synchronous, only the clock dependent, the data will be transferred. So this is about USART is the synchronous protocol, UART is the asynchronous protocol. Getting right?
Yes.
Okay, so and another important point, it is a full duplex mode configuration is possible by using the two wires. So this is a major advantage of UART. So and based on the software configuration, okay. So like what we know about the half duplex and full duplex protocol. What is the mode of transmissions? We have a full duplex, simplex, full duplex, off duplex. Did you remember on the network concepts?
Yes, yes, sir.
Yeah.
Simple duplex.
Yes. So whatever the software on we have, right, with the configuration, you are able to switch this UART as a part of full duplex, as a part of off duplex. What is a full duplex and what is off duplex?
Full duplex. Yeah, full duplex is it is a two-wire communication. Yeah, two directions.
Two
Full
direct
duplex.
communication. Off way is one should be
Yeah, it is
communicated.
one-way communication.
So in the software configuration, like we can make it this UART as a full duplex or off duplex. But default, remember this is very important. The default UART is a off duplex protocol. This is a default is off duplex protocol. One can be sent, one can be received. If you change the configuration in the UART software, that can be changed easily. It will work both transmit and receive at a one time. This is a flexible, so that's why we call it as a universal. Because of the mode we can change, we can communicate with the devices very easily. Okay, so that's what the universal it is. Getting right? Universal, asynchronous, receiving and transmission. We can change the modes, we can change the anything we can change. Apart from that, baud rate, we can change the baud rates also. Okay, so you are getting right. What is the UART? UART is a asynchronous protocol. It is a off duplex protocol. Okay, so UART is the off duplex protocol. Okay, so just how you need to make the full duplex. In case you need to achieve the full duplex, what are the matter? You should have a separate data line. Oh, this is additional information you don't want to consider, just for understanding. So to achieve the full duplex data, you should have a separate data line, and timing constants you need to change, and you need to be hardware supported. These are some wire pins. Okay, so we have 9-pin connectors generally. 9-pin, as I told you in microcontroller like serial port, we have a 9 pins. So that 9 pins, one pin will be act as a transmitter, other pin will act as a receiver, and other pin it should have a CTS and DTA something we need it. Okay, like this we need. So these are some part of hardware supported things. And software implementation. So once you are the hardware is ready, you need a software implementation also. So that's how this UART protocol will work. Getting right? So in real time, like we should have the this is the microcontroller, the ECU we called, and you are able to see what is this port? It is a USB port. So where is our UART is coming then? You need here. This is a converter. USB to UART converter. So because in laptop we cannot, we don't have UART, right? 9-pin connectors we don't have. We need some USB pin. So with the help of this pin, we are able to convert. We can connect. Okay, so to convert this UART, we have the USB to UART converter. Okay, whatever 3-pin wires that you are getting from the controller, so that will be converted and it will be going to the USB. Getting right? Is it clear for you all? I mean, how the protocol we are connecting to the ECU, and if in case in our PC if the UART is not there, that what is the converter we are using? USB converter. Internally, it have this. Okay, so to understand physically, like the laptop is and the USB cable we have, and see USB to UART. Here, what is the serial converter here? What is a serial converter? USB to serial converter. UART only, right? So UART is my protocol. So here we have the ground, TX and RX, and this is our microcontroller. Okay. So whatever we are giving the plugin, right? So plugging of the microcontroller, it have the pins. As I told you, the DB9 connector pin. Here we have the one numbering 1, 2, 3, 4, 5. The numbers will be there. To identify this, always remember it will be like a V shape. The more numbers, whenever it starts, you have small dot here generally from 1, 2, 3. It will start like this order 5, again 6, 7, 8 like that. And which is the TX pin and RX pin? So TX is, which is the pin? 3 and RX is 2. Okay, so that means whichever the pins you have, it is a male connector, and the female connector, it have the holes. So that will be with the help of this female connector, we are able to connect the other devices. Getting right? These are the male connectors. So, but usually the pin naming will be there and the numbering will be there. Getting right? Any other doubts on this? How the serial communication we are connecting it? So what are the wires? How we are connecting the wires? Is it clear? Vardhan, Anil? Any doubts on this till now?
Yeah, no doubt. So.
Okay, why UART is using? We are using for sending and receiving the data. So it is used to convert incoming and outgoing data in a serial binary string. Who will convert this? USB. USB to serial converter we are using, right? So what it will convert? It will convert the incoming and outgoing data from PC. From PC, it is converting to serial data, okay, and into the serial binary system to the microcontroller. And from the microcontroller, the data you will get in serial way, it is converted into data in the USB form, in the packets or the frames, we say. So then you are able to access in the PC. So next, when whatever receiving and sending,